Well, once you've done addition, I guess you have to talk about subtraction somewhere in there. We won't use subtraction very much in the multivariable calculus course, but when you're in a physics, mechanics course, or engineering course, vector addition and subtraction are pretty important tools to have. So, quick little brushing up on the topic of subtracting two vectors. I'm going to quote my mentor from years ago, and my mentor would say, "There's no such thing as subtraction. There's only adding the opposite, or adding the negative." And so you could certainly define subtraction that way if you wanted to, but since we learn how to subtract when we're very young, it probably still is going to feel like subtraction when we look at it. Let me just give you some numerical and visual cases here. I minus 4j, there's one vector. So if we start here, that would be right 1 and down 1, 2, 3, 4. That would be vector u. Vector v is negative 3i plus j, or 1j. And instead of getting ready to add these two, let me just sort of ask, well, what is the opposite of vector v equal to? That's called a scalar multiplication. Well, that would be positive 3i minus 1j. So if I do that from here, 1, 2, 3 to the right and 1 unit down, that would be the opposite of vector v. And then using our, what was it called? Tip to tail method, then this would be the adding the opposite vector. That would be vector u minus vector v. Or we can just do some arithmetic. Vector u minus vector v. 1 minus a negative 3 is positive 4. Negative 4 minus one more is negative 5. And that would be the red vector here. Right 4, down 5 units. Ta-da! Subtraction, not too difficult. Now let me show you a different visual example. Remember, you have a pause button if you need it. Okay. So we've seen these two vectors before in the addition related examples. And in this particular case, I'm going to save us a little bit of time. Vector u right here is right 2 units and up 6 units. And vector v down here is right 3 and up 1. Notice I've switched back to my component notation. Takes a little bit less space and it's almost more readable. If I do the subtraction, I will get 2 minus 3 is negative 1. 6 minus 1 is, oops, that doesn't say negative 1, does it? I'm not even going to reshoot this video. We're just going to fix it. Negative 1. 6 minus 1 is positive 5. Real life happens. Deal with it sometimes, huh? If I had to turn this in, you know it would be reshot, but I like to demonstrate my mistakes occasionally to my class also, so they know that I am a human being. This isn't some sort of a cyborg hand that you're looking at. Now, enough chit-chat. Where is this vector on that picture? Well, I think you'll find if you start here and go left 1, 1, 2, 3, 4, 5, it happens to be the third side of this triangle. This is the vector u minus v, or negative 1, 5. If you start here and you go to here, it would close in the third side of this triangle. Now there are rules to note. How do you know how to draw the subtraction of two vectors and complete the triangle if the first two vectors begin from the same point? It's not something I'm going to need for this particular course, but if I was teaching a vectors course, we would do some more examples like that. So again, for review purposes, this shows you what I needed to show you. If you need more vectors, then this is not the channel to give you the full vectors, at least this particular set of videos. Until next time, some good stuff coming up.